All right, so page 103. So it says graph and label the coordinates of the vertices of trapezoid A, B, C, D. So we have A, B, C, D right here. Let's go ahead and plot these points. So 1, 2 for A, 7, 2 for B, 7, 5 for C, 3, 5 for D. So if you go ahead and plot these points, you would get a trapezoid like this, okay? So letter A says draw a diagonal AC and trapezoid ABCD. So diagonal AC, so you would just basically connect these 2 points A and C and make a diagonal. So what right triangle can be used to determine the length of a diagonal AC? So I labeled it as X. So to figure out this X right here, what triangle can we use? Well, we can use this, right? We can use this ABC triangle to determine this side because we know that this is the hypotenuse and the two legs are given. The way I got 6 and 3 is by counting up or finding the distance between A and B. So 7 to 1, so the distance right here is 6. From here to here, this is 5, this is 2. So count up 3. So this is 3, this is 6. So knowing that, to figure out the length of this, the hypotenuse, would be just to do a squared plus b squared is equal to c squared. So in this case, it would be 3 squared plus 6 squared is equal to x squared. So 6 squared is 36 plus 3 squared is 9, which is 45. And so we would take the square root of 45 to figure out x, so which is 6.7. So that means diagonal AC, or the segment AC, is 6.7 units. Letter D, draw a diagonal BD. So you're going to do this on your own. Go ahead and draw a diagonal across right here. And what right triangle can be used? So right triangle, right? So let's say there was a diagonal line drawn right here. And notice how we are going to have this side of this triangle and this triangle. So notice how this would be the right triangle that you would use. So it's going to be BCD. So triangle BCD. And to figure out this length right here, once again, this would be the hypotenuse. This is still 3, and this would be 4 because it's from 7 to 3. So this would be 4. So 4 squared plus 3 squared should equal to this squared. So the work is as follows. X squared is 25, so to take this, to get x by itself, take the square root of 25, which is 5. So that means diagonal BD is 5 units. So what can you conclude about the diagonals of this trapezoid? Well, for AC it was 6.7, for BD it was 5. So obviously the diagonals are not equal in length. Okay. The diagonals would be the same for the isosceles trapezoid. So isosceles trapezoid has two opposite non-parallel sides that are the same length. So for example, this one is not an isosceles trapezoid as this. So notice how this pair right here, CD and AB, those are parallel, so we don't count that. But this AD and BC are not the same length, right? So it's not an isosceles trapezoid. So if it was an isosceles trapezoid, then the diagonals inside would be the same. But in this case, it's not.